Hello everyone, my name is Rakesh. Today I'll discuss about the properties of expectation of a random variable. So the expectation itself indicates the average value. The expectation of x, some random variable, can be written as minus infinite to infinite, minus infinite to infinite x into fx of x into dx, where this x fx of x indicates the probability density function and x is called as a random variable. Coming to the property number 1, that expectation of a, which is a constant. So if we want to find the expectation of A, means we can simply substitute the value in the formula of expectation. We can write A here and the probability density function here. So if we take out A, we'll get minus infinite to infinite fx of x into dx. So this is called as the area under the probability density function, which is always equal to 1, and the expectation of A is equals to a constant itself. A is called as a constant. So expectation of A, which is a constant, is equals to constant. Coming to the second property, expectation of Ax, simply we are just multiplying with x here. If we change the x here, this x into fx of x can be written as, this can be modified as expectation of A into x is equal to A into minus infinite to infinite x into fx of x into dx. This is simply written as expectation of x. So expectation of A into x equal to A into expectation of x. We can write here as A into expectation of x. Coming to the third property, we can simply apply this. So we can separately write expectation of ax plus b can be written as expectation of ax plus expectation of b. This can be written as A into expectation of x plus constant is b. And we can write this. So the expectation of x plus y can be written as minus infinite to infinite x plus y into fx y of x comma y into dx dy. So this is called as a joint density function of x comma y. So this can be written as minus infinite to infinite x into fx y of x comma y into dx dy plus minus infinite to infinite y into fx y of x comma y into dx dy. So expectation of x plus y can be written as minus infinite to infinite x into integral of minus infinite to infinite fx y of x comma y into dy dx plus minus infinite to infinite y into minus infinite to infinite integration fx y of x comma y dx into dy. So this bracket function can be written as the marginal density function, which is fx of x, and this bracket function can be written as the marginal density function fy of y. So if we are modifying this, we'll get x into fx of x into dx plus minus infinite to infinite y into fy of y into dy. So this is the formula for the expectation of x, where this is the formula for the expectation of y. So finally, the expectation of x plus y can be written as expectation of x plus expectation of y. This is the proof for this one. So we can write as expectation of x plus expectation of y. So similarly, we can do this one. So as it is a linear operation, we can simply write as A into expectation of x plus b into expectation of y. And later, this operation can be performed as where expectation of x. So this expectation of x is a constant value. Expectation of some constant is always some constant. That is expectation of x only. Thank you.